All right, good morning, good afternoon, good evening, wherever you are. I hope you're doing great. We're going to finish up section 5.3 today, the centers of triangles, and work our way towards the inequalities in triangles later on in this chapter. So, like I said before, some of the terminology are terms that we haven't covered a whole lot. You're not going to hear a whole lot in other classes, and so it's very important that you learn the terms and know how they relate to each other and be able to apply them on the test. And so, real quickly here, I want to run down two of the terms that we started talking about yesterday. The first term would be the circumcenter. Circumcenter. Okay, and the location of the circumcenter is going to be where your perpendicular bisectors meet. So you want to write that in the second box right there. Where perpendicular bisectors meet, okay? And the use/purpose, I think the best thing is probably to describe maybe you've got three different locations of maybe some companies, buildings. Let's say you're a manager at Kohl's. You got three different Kohl's stores located in general locations, and you have to figure out a distribution center, where to put the distribution center that's going to be the same distance from all three of those. And so that'd be a great time to use your circumcenter there, okay? The next one we talked about yesterday was the incenter. Incenter, okay? And the incenter you want to put for the location is where the angle bisectors meet. Okay, where the angle bisectors meet. Now, the incenter is actually really interesting. If you ever have a triangular shaped object, if you put your finger on the incenter, that is a location of the gravitational center of the object. So you want to spin a triangle, locate the incenter, put your finger underneath that, and then you can spin it. Okay, it'll sit there right on your finger. And all the weight will be evenly distributed amongst the triangle, whatever the object is. If it's metal, if it's paper, if it's, whatever it is. The end center is the gravitational center of the object, okay? Now, use/purpose, you could put down the gravitational center, okay, where the weight is all evenly distributed if you find the end center. You could also put down, and the use or purpose is, let's say you've got three busy highways, or three roads that are passing by, and you want to put a store in its location that's going to be the same distance from all three, okay? The roads themselves, all right? And so, yeah, that's when you could use the incenter. So maybe I should back up to circumcenter. I was getting a little ahead of myself. The use of the circumcenter is a point equidistant from the vertices of the triangle. You want to make sure you got that down there. The circumcenter is a point equidistant from the vertices of the triangle. Okay. The incenter, the location, is going to be a point equidistant from the sides of the triangle. All right. Now, what we're going to do next is I want to show you something real quickly here. Let's see here. I know it's one of my famous videos here, but I'd like to go ahead and show you two more centers that occur within a triangle. Okay. The first one is the median, is a segment that joins a vertex to the midpoint of the opposite side. So if you actually want to write that or add that to your vocabulary sheet, I don't think it's on there, but the median is a segment, and here's the exact definition, whose endpoints are a vertex and the midpoint of the opposite side of the triangle, okay? You can go ahead and add that there, and I'm okay with that as being part of your vocabulary sheet, okay? Now, there's something interesting that happens within a triangle when you look at the medians, and I'm going to go ahead and show you right here. This segment length is 14, I made a mark at 7. That segment length is 10, I made a mark at 5. And this last segment length is a length of 8, I made a mark at 4. And so I'm going to join the vertex to the midpoint of the opposite side of each one of these. And what you're going to notice here is that these medians are all concurrent at a certain point. Okay? And that point is called the centroid. Okay, takes me back to my days when I would play video games. There's a video game called Centroid that I used to play. Sorry, side comment. Anyways, taking a look at the relationship now, what occurs, the centroid, if we look at this length that's going to come up here, is it coming? All right, so let's go back just a smidge. All right, so I took the length of DF with my compass here, and I'm going to compare that to the length of AD. And I hope in your head you're kind of guessing, I don't know, is it 1? Is it 2? Is it 1.5? Is it 3? I hope you're not saying 3. But what you notice here, if I take the length of DF and I use that compass, I'm showing you basically that the length of AD is twice, if you look at that, twice the length of DF, okay? Now the next thing I was just doing, I took the length of ED and I'm going to compare that to the length of DC. And so if we look here, well, it looks like DC is going to be twice the length of DE as well, okay? And so, well, that's convenient. Well, let's see if it happens on the last median as well. If we take a look at the last median, this length right here, if I convert that up here to BD, okay, we've got that length there. And what we see here is that BD is twice the length of DG. So how does this all play out? How do I want to see, let's see if I can get rid of this. Okay. Well, if I'm giving you problems on your homework, test, quiz, I'm probably going to do something like this. If DF is a length of 9, what is AD going to have to be? And I hope that you're thinking to yourself 18, because this length is twice that of this length. Okay? Now if I change it around, let's say I give you AD is a length of 20. Okay? What would DF have to be? Well, if this is 20, there's 2 of these to 1 of these, this would have to be 10. Okay? If I were to go ahead and give you the whole length, let's say is 24, what would the length of this length have to be? Well, you notice here that the whole length of AF, there's 3 segments here. There's 1, 2, and 3. So if I divide 24 by 3, I get 8. So this length right here would be 8, and this length here would be 8 and 8. So AD would be 16, and DF would be 8. So we get a total of 24. Okay? So again, that's how this is going to play out over the next couple of minutes here, as far as I want to make sure that you can see everything that you need to see. Now, the next thing that we want to cover is this, an altitude of a triangle. Now I know you guys all know what an altitude is, or you should, because you've had it in previous classes. But if you want to add this definition again to your vocabulary sheet, you can. An altitude of a triangle is the perpendicular segment from a vertex to the line containing the opposite side. Now, why does it say a line containing the opposite side? Let me go back here real quick. Obviously, if I'm going from this vertex, a line perpendicular to the opposite side would be right there. Okay, so it's this line right here is the altitude. How tall is that triangle? That would be one altitude that I could use. Okay. In a right triangle, we can use one of the sides, one of the legs. So this leg would be an altitude, or this leg would be an altitude. Okay. And in an obtuse triangle, if I want to know how tall the triangle is, I have to go outside the triangle. So this is a segment perpendicular to the opposite side, a line containing the opposite side. So again, hopefully that made sense to you. Now what's interesting is I only put one altitude in here. The altitude, there would be an altitude that would probably be something like this, a right angle there, and then a right angle up in here. Okay, so all of the altitudes meet on the inside. This one right there would be a right angle. Obviously we already talked about that one. And then perpendicular to the opposite side, we're probably looking at something like that right there. So that point right there would be where those 3 altitudes would meet. This one right here gets a little more complicated. Drop that line down perpendicular, it's going to go down. This line perpendicular would go here, but I could continue in the opposite direction. And then if I extend this line out right here, from this vertex, the line perpendicular to it would be outside the figure as well. Okay? So, what we notice here, and I'm just going to speed through this next part. I'm going to go ahead and draw the 3 altitudes within the figure, and the 3 altitudes actually have a point called the orthocenter. Okay, so you can read over this. The altitudes of a triangle are concurrent, which we know they are. We can see that right here. They meet at point G. And the point of concurrency of the altitudes of the triangle are called the orthocenter. Okay. All right. Now, as I continue on, the question then becomes is, where would the orthocenter lie with an acute triangle? Well, I'd hope you know that it would lie inside. If you look at the altitudes from all 3 of the vertices, they would intersect right there. The next one, I believe, is the right triangle. Obviously, we've just talked about a little bit ago, the point where they would meet would be right there. This angle is a right angle right there. And then the obtuse triangle, this is the hard one. It's going to meet outside of the obtuse triangle. So the orthocenter would be right there. Okay? Now, with that being said, I want to look at this worksheet right here with you guys to make sure you understand the terminology that we've been working on the last couple of days. Okay? And so what I'd like you to do is I'd like you to identify these different terms within the 5 figures down here. Okay? Now, I would prefer that you pause your computer and try to do it on your own, because I think you should be able to. But if you can't, you can play it again then. So these 5 figures, let me go ahead and go through these. Perpendicular bisector. Remember, it forms a right angle and cuts the side in half. So right here, I see a right angle, but it doesn't cut a side in half. This one cuts a side in half, but we don't know if that's a right angle. This one right here, right angle, cuts a side in half. We know that AB right here is a perpendicular bisector. This one, we don't know if it cuts this side in half, and we also know that it doesn't look like a right angle. Okay, and this one does look like a right angle, but we don't know. It definitely doesn't cut this side in half. Okay, so again, this one is the perpendicular bisector. The angle bisector cuts an angle in half. This one doesn't cut any angle in half. This one might cut an angle in half, but we can't tell for sure. We don't know for sure. This one definitely doesn't cut an angle in half. This one does. So this one's going to be your angle bisector. And this one definitely does not cut an angle in half. Okay. Altitude. Remember, it comes from a vertex perpendicular to the opposite side. So if I look here, does AB come from a vertex? Yes. Is it perpendicular to this opposite side? And it is. So this is an altitude right here. How tall is that triangle? Altitude. I oftentimes say when I'm looking for the altitude, I say how tall it is. And I want you guys to think, when you go to the doctor's office, what do they say when they're measuring your height? Stand up straight. Okay. Why is that? They want you to form a right angle with the ground to get your actual height. If you slouch or lean over, you're going to be like this right here. You're not actually getting the full altitude. Okay. Undo that. Sorry, guys. There we go. Okay. Now, obviously this is a perpendicular bisector. This one right here, it is coming from a vertex, but we don't know if it's a right angle. We've talked about that already. This one is coming from a vertex, but it's not forming a right angle, and so we already know that's the angle bisector. This one, it's coming from a vertex. Actually, it's part of the vertex, and it is forming a right angle with the opposite side. So it's one of those right triangles where it does form a line perpendicularly opposite side. That would be your altitude right there. Okay. Next one, median. Well, we know this is the altitude. This one coming from a vertex to the midpoint of the opposite side. When I think median, I probably should have told you this earlier. Median is like the middle number. Okay. And so I want you to think, those of you that are driving, if you're driving in the median, you're probably going to get picked up. Okay, where's the median? It's in the middle, like the grassy part on I-75. Okay, and so we don't want to drive in the median. And so when you think median, think middle. So vertex, middle, opposite side, that would be your median right there. Okay, this one is going to the middle of this side right here, but it's not going to the vertex. If it were coming from the vertex to the midpoint of the side, then it would be considered the median. This might be the middle, but we don't know for sure, so we can't say that's a median. And this one's definitely not going to the middle of the opposite side. Okay? So again, if you didn't catch all that, altitude, median, perpendicular bisector, angle bisector, altitude. Okay? All right, now, if we go to the back side, you actually need to go ahead and, let's see here. Okay, I guess I didn't, excuse me. When I initially brought up the document, this document right here, guys, I wrote circumcenter on the board, but I was using the wrong technology there. So you want to put, again, that was circumcenter and then in-center and then the location where the perpendicular bisectors meet, where the angle bisectors meet, so on and so forth. So I apologize about that. I didn't know it wasn't showing up on my board until after we got done there. All right, so here's what I want to do next. Let's go ahead and take a look at the back side of your worksheet there. And here's what we have. I'm going to do this first example with you guys, and then we'll do the last example. I'll let you do the last example on your own. Now, okay. So here's what we have on our paper here. D is the centroid of ABC triangle. So this point is the centroid. And we know that DE is 6, and we have to find BE. All right, so if I go ahead and put down that this is 6. Remember when we watched the video a little bit ago that this segment right here, if I double it from the centroid to this point over here, that'll give me BD. So BD, I know, is going to be 12. And so as a result, I know that BE is going to be a total length of 18. 12 plus 6 to give me 18. Okay? Huh. Why is that not working? Okay, let me see if it'll work now. No, it's not. Oh, here's why. Okay. So let me reiterate what I was doing just a moment ago. Clear that. Okay. So again, D is the midpoint, or the centroid right here, and we know that this length right here is a length of 6. Okay. So the question then becomes is what is the length of BD going to be? Well, we know that if we take the centroid to E, that length being 6, this length right here has to be twice as much, which is going to be 12. And so from there, 6 plus 12 gives you a total length of BE, which will be a total of 18. Okay. AF, well, F isn't up there. I'm going to put F right there. AF is a total of 12. And we need to find AD and DF. Now, remember, this length right here, if I go ahead and double it, I get this length right here. So if I were to go ahead and measure this with a compass and come down here, I'd probably have a mark here and a mark down there. So how many total congruent segments do we have right here? Remember, there's 1, 2, and 3. So if I go ahead and take 12 divided by 3, that gives me 4, okay? Now, which length is 4? Is it AD or DF? Well, I hope that you can see that DF is going to be the length of 4. And so what does AD have to be? Well, it's 4 plus 4. That'd be a length of 8. Okay, so again, AD is a length of 8, and DF is a length of 4. Okay? Now, for the next one, let me do this. Get rid of some of this stuff so we can see a little better. Okay. We are told that DC is 15, and I want to find DG, and I want to find CG. Well, remember, if I take this length and double it, I get this one. So if I cut this length in half, I get this length up here. That would be a length of 7.5. Okay, so from the centroid to G, that would be a 7.5 units. Now from there, excuse me, to get the total length, I'm just going to add 15 and 7.5. And so 15 and 7.5 gives you 22.5. Okay? So again, it's understanding that 1/3, 2/3 relationship or 2-to-1 ratio, whatever you want to look at it or how you want to view that. All right, I hope that made sense to you based off the video you saw a little bit ago. So now what I'd like you to do is go ahead and try the next problems on your own. So take a moment and see if you can figure out what those next 3 problems will be. Okay? Pause your computer and do that for me. Okay? So basically, where all these medians meet, that's where the centroid's at. Okay? And so what I'm going to do is I'm going to fill in what we have. We have WM, which is the length of 16. Okay, and we want to find WX. Now, before we can find WX, we need to find MX. Okay? So I hope that you're thinking through the process here. To get MX, I have to take this and divide it by 2. Remember, this length here, if I double it, I get this one. So if I have this one, I have to divide it by 2 to get this one. So this would be a length of 8. MX would be 8. Okay? So to find WX, I'm just going to add 8 and 16 to give myself a length of 24. Okay? M is the centroid of WOR, and so ZM is 6. The question then is, what is the length of MR? Well, remember, this length right here, from the centroid to that midpoint right there, if I double it, I get this length over here. So if I double 6, I get 12. MR is 12, so therefore ZR is going to be 12 plus 6, which is 18. Okay? And last one, M is the centroid of WOR, and YR is 4. WOR, YM is 4. Let me clear some of this off so we can see a little bit better. YM is 4. So we want to figure out what OM will have to be. Well, that's pretty simple because we can tell it, if I take this one and I double it, I get this length right here. So that length will be 8, and we know that OM will be a length of 8. Okay? Now, let me just say this. If any of you are looking up here going, how's he getting that 1 to 2 ratio? Okay? How does he know that this length doubled is this length? Go back and watch the beginning part of the movie here, where you've got that video and I show you with the compass. I hope it's clear. I would have much rather presented this in class, but with the time commitment and the debate today, I just couldn't do that. So if you have questions, come back and see me. Otherwise, have a great night, and I look forward to seeing you tomorrow, and make sure you get the homework done as well. Thanks. Goodbye.